In the previous class, we have known about the parallel and series grouping of cells, and we have developed their formulas. Now, based on these series and parallel groups, we solve some problems and see how the grouping of cells problems are solved. For example, find the equivalent resistance between points A and B. That is, here a group of cell is given and it is connected, and we have to find the equivalent resistance between point A and B. That is, if point A is connected to external uh, um, cell, then what will be the equivalent resistance in place of these two resistance? So simply it is shown here that one end of these two cells are connected at one point and another in at another point. So it is in parallel. So we should apply the formula for parallel grouping. So R parallel will be equivalent resistance RP represented by R1 R2 by R1 plus R2 and 3 into 4 by 3 plus 4 12 by 7 ohm. Answer. In this case, we see that these two are in parallel, but these in series. So first we have to calculate equivalent of these two, and then its equivalent will be parallel in with this resistor, and we have to find the equivalent resistance between A and B. So point A and B. So first we let calculate its equivalent resistance, which will be, that is hence the equivalent of these two will be 3 into 2. 3 into 2 divided by 3 plus 5 equal to 6 by 5 because these are in parallel. Now now this equivalent will be in series with this resistor. So we have shown here in figure, and because these are in series, so we can apply the formula for series. Rs equal to, or R equivalent equal to this plus this. So 6 by 5 plus 3 equal to 21 by 5. Next, question is find RAV, that is equivalent resistance between these 2 points. We have to find, and that is equivalent resistance between point A and B. Here again two points are, one is connected at A, and here we should keep in mind that if this point here, if there is no resistance, it means that this point can be placed at this point, because there will be no potential drop along this line. If there is no resistance, then at every point it is assumed that potential is same. So from here to here potential will be same. Similarly for B, from this point to this point potential will be same. Now here we see that these are in series. So first we calculate the equivalent of these, and then this equivalent will be parallel with this resistor. So we have calculated 2 plus 2 4 in series, R1 plus R2 equivalent resistance is given in series, and now it is in parallel. So we applied formula R equivalent or Rp equal to R1 into R2 by R1 plus R2. So 4 into 4 by 4 plus 4, 16 by 8 equal to 2 ohm. Answer. Next questions are here given. We have different arrangement of a resistor, and we have to find the equivalent resistance in this. For example, find the equivalent resistance of the network shown between the points A and B. So here we have to find the equivalent resistance between point A and B. Here in this problem 1, point A is at this point, this is A point, and this is B point. Again in this figure, point A is at this and this is B point. In here it is A and it is B. In 4 point, this is A and this is B. And in 5. This is point A, this is point B. So let's solve one by one. Let first we solve question number 1. Here it is shown we have to find the potential difference between A and B. So first we see which are in parallel. So first we see that in this point and this point, these are in series. So these we can find the equivalent of these two, and will be parallel to the this resistance. Here it is shown because R plus R equals to 2R. Now from this B point and this point, here name is not given, but you have to understand that. Now these are in parallel, so this will be replaced by its equivalent, and its equivalent will be R into 2R by R plus 2R. So here we have shown here. Now these two will be replaced by one equivalent resistance R into 2R by R plus 2R equal to 2 by 3R. Now here this will be single, so now this and this will be in series, so this will be add up. So here now now this two will be replaced by equivalent single resistance. Here we have replaced it, and here it is shown. That is because these are in series, so 3 by 2 R plus R equal to 5 by 2 R. Now these two are in parallel group, so R equivalent will be 5 by 2 R into R by 5 by 2 R plus R. Solving we get 5 by 8 R answer. Similarly, other problems can be solved by analyzing the problem. For here, in the second number, we have to find a point A and B. So if we take this point in this side, now B, and this will be left A in this side. Because this is a wire, so we can replace it any direction. Now if we see now if we see, these all are connected to the, because in there is no resistance here, so we can consider these all are replaced by a single point B, because in this there is no resistance. So for example, end of this resistance is connected here. Again, end of this resistance is connected here, because there is no resistance between this in this line. So both this point will be at one point, because there is no potential drops along this line. So we can connect it to one place. Again, we see that this is in this point and this point there is no resistance, so this whole point will be connected at one point. And again we see that in this line and this line there is no resistance, so it will be a point B. Here it is shown, so B will be so these three are in parallel and this is are in series. First so equivalent resistance we calculate parallel, applying parallel formula, which will be equal to R by 3. If resistance are equal, then we know that Rp is equal to R by N. So applying this formula in parallel grouping, so this is the equivalent resistance of this. Now in point B and A, and these two will be in series, so R equivalent will be R by 3 plus R equal to 4R by 3. Next, in this case, if we see then this will be in series, so this will be replaced by one equivalent resistance as shown in this figure, and this will be 2R. and this is the case of Highland Stone bridge. So there will be no this resistor can be removed. We will discuss about balance with stone bridge in the next in the mm, in the next class, further class. So it will be replaced by, because in when in the condition of valence hit a stone bridge, in this point and this point remains at same potential, so there is no current through this. If we uh, apply it to the external cell, there will be no current in this part, so this can be removed. So we have removed it, and now this will be, this is in series, again this is in series, so equivalent of this again will be in parallel, which is shown here. Now equivalent of these 2R and 2R, so and finally A and B is these two are in parallel, so R equivalent will be 2R into 2R by 2R plus 2R, 4R square by 4R equals to R answer. Next, our next problem is this is our next fourth number. Here it is B, and here it is clear that from this C here, this point is, if already, because there is no resistance between this point here, here and here, so this can be considered that, yeah, that these all are at one points, and at one point here we see that this resistance is also connected to B. This resistance is also connected, this end of resistor is also connected to B. Again this resistor, in this resistor one end is also connected to B, and in this resistor one end is also connected to B, and all other ends of all resistor is connected to A. So we can say that these are in parallel as shown in figure. So here it is shown A and B, these are in parallel, so we solve it, get its R equivalent will be equal to R by 4 or RP. We know that R in parallel, if resistance are equal, then equivalent resistance becomes R by N, so this is will be R by 4. Now again in this question number 5, here we see that this is the point A, this is the point B, and if we see, again we see that if we stretch this point in this direction and this point in this direction, this will be in middle like this. This will be shown like this, because these two are connected. These two are connected at one point, but this is connected at this point, and so this will be in shown. The next figure will be like this, and this is a balance with test on bridge, so it will be removed. Now this the final figure will be this, and now this is in series, and again this equivalent will be in parallel, so we can solve. So finally we have 2R by 2R, A and B. Now these are in parallel, so R equivalent to R into 2R by 2R plus 2R, 4R square by 4 equal to R answer. So these are the case of solving different types of circuit, and now we can solve another using this concept, parallel and series connection method using. Next, again we have similar question like here. Find RAB, that is we have to find the resistance between A and point B. Now it is a this is figure 1, this is figure 2. We have to find the equivalent resistance in these two, point A and B of this network, and again this network. So first we let solve this. because there is, this is not in uh, connect, this is in open circuit, so this is of no use. Our circuit will be like this because current will not flow in this direction because it is not connected, it is not closed. So we have to see only this part. Now in this part, these three are in series here. In these three are in series. So equivalent of this will be parallel to this. So here we are showing 3R is parallel to this. Now these two are in parallel. So this again replaced by one single resistance in series with these two. Here it is shown. R, and this will be R into 3R by R plus 3R. And now these are in series. So we have 3R by 4. Solving it, so hence RAB will be, that is equivalent resistance between point A and B, R plus 3R by 4 plus R, 11 equals to 11R by 4. Answer. Next, the second question we here see that if we see here that this is point A and this is point B. Now if we see these are in series, so and this will be replaced by one equivalent resistance. Now this will be parallel to this. Here it is shown. First we replace it in by equivalent. So 2 plus 2 will be 4. Here it is shown. Now these two are in parallel, so it can also be replaced by a single resistance. And but it will be in parallel, so 2 into 4 by 2 plus 4, equivalent resistance of these two. Here it is shown, and here it is shown again. Parallel part is calculated, and this parallel will be replaced by one single which will be series to this. Here it is shown. 4 by 3 is in series to 2. Again this is in series, so this can be added and replaced by a single resistor which will be parallel to this. So again this is in parallel and its value is 10 by 2, 10 by 3, and this is 2. So applying formula for parallel equivalent series in parallel, equivalent resistance in parallel. So this will be 10 by 3 into 2 divided by 10 by 3 plus 2. Here we have calculated, which comes out to be 5 by 4. Now these two are in series, so this will be also replaced by a single resistor. Here it is shown, and that will be 13 by 4. Now these two are in parallel, so finally we get equivalent resistance between point A and B equal to 13 by 4 into 2 divided by 13 by 4 plus 2. Solving we get 26 by 21 ohm. Answer. Again we have to solve the problem. In this case here again point A, in this point A and B we have to find the equivalent resistance, and this point A and B, here we see that easily we see that these in series, again this will be in parallel, and again this will be in series, and in this part A, this is in series, so this will be again this parallel, and finally it will be in series with this. Now all three resistors will be in parallel to each other, and so we can calculate.